Hello, everyone. It's so nice to see you all here. I'm really flattered that you decided to come to my talk. My name is Maria Khalusova. I'm from JetBrains. You guys know what we do, right? How many of you do not know what JetBrains does? Oh, there's one person. Come to our booth. We'll tell you what we do. Everybody knows mostly IntelliJ IDEA. And not so many people know that we do other tools as well. So the whole thing with IntelliJ started when we wanted some smart Java editor. It's not like there were no Java editors at the moment, but we wanted something smarter with refactorings and cool features, so we created IntelliJ. And the same story pretty much happened to all the other tools that we have. When some years ago we create our own continuous integration server, then there was issue tracker, and some time ago we started doing code review, and we tried a few tools, and we ended up building our own, naturally. But today I'm not going to be talking about the code review, the tool that we have. We're going to talk about the practice itself and how to make the most of it. What are the things to consider if you haven't started doing it, or if you're already practicing code reviews, how to be better at this. So how many of you already do code reviews in your... Okay, so I'd say about 50-50. Okay. Before we start, I just wanted to ask, if you have any questions, you can fire them at me on Twitter. That's going to be easier, that you don't lose your thoughts, and then I will be, 100% sure to answer it. So my Twitter handle, I don't know if you probably can see it, it's in the right bottom corner. Okay, so code review. The idea normally that people say when you ask about code review, what do you expect from code review? People say this: finding bugs. And to tell you the truth, it's only a little part of what code review actually gives to you and your team. And we've been doing this, the code reviews in our teams for a while, and we have discovered there's so many other things to it. One thing is team collaboration, because the whole team can engage in a technical discussion over the code base and the context of the code base, and solve problems together. And it's very efficient because you communicate exactly in the context of what you're doing. Then, of course, there's knowledge sharing. You learn from each other. You learn from senior developers. You all have different areas of expertise, different backgrounds. So it's a great way of learning from each other. If you have new team members, it's much faster to bring them on board if you make them review codes that you already have. It increases buzz factor. Who knows what it is? Okay, it looks like I need to explain it. So the whole idea is you have your team. How many people would have to be hit by a bus so that the rest of the team doesn't know what to do anymore? So pretty much, if you have a module and only one person knows what's going on there, the number is 1. You hit this person with a bus, and nobody has a clue what to do now because nobody knows what's happening in that module. So in ideal world, everybody knows about everything. It's not always achievable, of course, but you want to increase it as much as you can. So the more people, you want to make more people know about the majority of the stuff that you already have. And code reviews help with that, because basically there are 2 ways to increase this factor. Either everybody commits everywhere, or everybody reviews everything. And then, of course, there is improved code quality. We do find problems, we do find issues. that's still one of the benefits of code review. And it helps to maintain the code, to make it easier to read, and so on and so forth. So in the end, these are all the things that you want to have as your goal if you are going to do code reviews. Not just finding bugs, but these are the aspects that you want to achieve as well. You want to have better team and better software, and code reviews help with that. There's one thing that you should not do if you want to adopt code reviews in your team, and there's this. Some people, mostly managers, are tempted to use it for that. And the problem is, if your team knows that code reviews are used to evaluate their own performance, or if they suspect that it might be used for that, they will do their best to look good. And they will not care about finding problems, learning, collaborating, finding solutions. They will be focused on one thing, not getting fired. So you basically cancel all the other benefits if you decide to use code reviews for this reason. So don't do that. This is what code reviews are and what they're for. The rest of the talk, I'm going to be talking about things that you need to consider, to keep in mind if you want to have a smooth start with code reviews, if you haven't started. But if you already have started, and if you see that some things are not exactly working, and you may go back to these things and maybe change something, then we're going to talk about how to make them really useful. Next thing is, what is it exactly we're looking for when we're doing a code review? What kind of problems do we want to address with code review? Because there are so many tools out there that already help you improve code quality, and there are so many tools that help you with collaboration. So what is it exactly do we need code reviews for? And the last thing, but not least, is human factor, because people are doing code review, people give feedback to each other, and there are so many ways it can go wrong. So I feel that it's important to talk about this as well. So as with any software practice, if you want to adopt code review, there are 4 key aspects that you have to have in mind. Your team. These are the people who are going to be doing code review in the first place. So you need to get them on board. You need to explain to them why do you want to do code reviews. Explain these goals that you want to achieve. They may have questions like, how is it going to change my routine? Will there be a new tool? And many other questions. So you have to explain the changes. You have to communicate the goals that you want to achieve. And you have to listen to their concerns. And then there is change impact. We're going to talk about this a little more in detail later as well. Process and the new tool. Now, I talked already a little bit about the team, and I said that you need to communicate the goals clearly. You also need to address the problems that your team may mention. Some people just don't like a change. Like, I'm happy where I am. I don't want anything different. It works for me. That's fine. Some people may have valid concerns that not understanding why do we do this, why do we need this, or how it will affect their process. And some may have had a bad experience before, like in that comic I showed earlier. So it's very important to listen to concerns and then address them, and then possibly adjust the process and work on the process with the whole team and bring everybody on board. Another important thing is cultivate code review culture. There are many articles and talks on this topic, but pretty much it means that you need to understand as a team why you're using code reviews, what for, and maybe work on some sort of checklist guideline. And possibly you may or may not need to talk to some of your colleagues, or maybe all of them, about how to give feedback to each other. That's also part of a code review culture. The change impact implies 3 questions. Who is going to do reviews? Now, if you have a team, if you have a startup and there are just 5 people in it, that's pretty easy, everybody. But it's getting a little bit more complicated if you have a company with hundreds of employees and you want to start doing code reviews. It may make sense to pick a team or 2 of early adopters and start with them, see how you need to adjust the process based on them. And then it's going to be easier to explain the benefits to the rest of the teams because you will have example before your eyes. Now there is what? If you haven't done code reviews before, it probably doesn't make sense to start reviewing everything you have. Normally it's better to start reviewing new commits that you have, and maybe later you may want to consider going back to what you had before. And then there's when. This one is pretty easy. But I still felt like it needs mentioning. You don't want to start doing code reviews 2 weeks before release or some major event. Nobody is going to appreciate that. And let's say 2 days before Christmas, nobody will care. After that, another key aspect is process. So this is pretty much how we do it. We have feature branches. A developer works on a new feature or a bug fix, then commits it to the version control, assigns somebody to review it. Then if there are problems found or if there are questions that need to be answered, then it's back to square one to the author who needs to address the problems or answer questions and clarify what's happening there. So the most important thing is you need to decide on the process and agree on the process with your team. And you need to look at the process that you have already. So for some teams, post-commit review works better. For some teams who already use pull requests, that's another perfectly fine way to go. You may want to think whether you want to review everything or just certain commits. For instance, if you have a critical system, reviewing everything makes total sense. You may want to specify, for instance, some just critical path. If the change happens to be there, then it needs to be reviewed. We're pretty much flexible. Some teams review everything. Some teams decide that they want to review particular changes. Some teams decide that developer can decide on his or her own that this particular change needs to be reviewed or not. But it's generally a good idea to keep workflows simple. The more rules you introduce, the more people you involve, the longer it will drag, the more time it will take, and the more it will create unnecessary confusion. You don't really need to overcomplicate your workflow. But we need to understand that code review is an iterative process, and iterations are good. It means that they actually bring something. Either there are problems found, or there was some misunderstanding. So when there are iterations, that means they are actually working. They actually bring something for you. Best practices suggest that average of 2 reviewers is the best number you can have. because first reviewer normally will find 50% of the issues, the second about 25% of possible issues, and after that it's a diminishing return and waste of time and money for everybody. But here's the thing, if you want to onboard team members, then it's probably better to have them review code and pair them with experienced developers, so this way you can kill two birds with one stone. So both find possible problems and onboard a new member. And it's generally better to review often, the same as with committing often. The more you review, the faster you familiarize yourself with the new changes and find issues and spread the knowledge. And then, of course, there's a new tool. Yes, you need a code review tool. Nobody does it in, I don't know, in a meeting or through emails or something like that. Code review tools, there are many of them. There are dozens of them on the market. You can find the one that you like that works for you. And they're good for doing code reviews asynchronously and keeping the history of discussions. What happened, why there was this solution. They're also good for sharing code with each other and providing the context in which you can collaborate. And it's important to find the right tool for you, but pretty much find the one that fits in your environment, works with your process. You may have some particular needs. For instance, how many of you use Git? Well, you will have no problems finding a code review tool. Almost all of them support Git. What about Subversion? Well, you still have some choice. Let's say ClearCase. Well, I don't have good news for you. But yeah, you may want to consider choosing a version control first. So, summarizing what I just said, if you want to start doing code reviews, it's important to have an open dialogue with your team about why are you doing it and how it's going to affect your process. You should have a good plan and you need the right tool. So at this point, you're already ready to start with code reviews. But now let's look how we can actually make the most out of them, how we can make them useful. And the first thing is, code reviews do not substitute all the techniques and tools you use to ensure code quality. It's not, it's a cherry on top of the cake. It's not the cake itself. So you still need to write tests. You still need to run them in a continuous integration server and use static code analysis. All the things that you do, you still need them. Code reviews do not replace them. And I don't know, spell checker and whatever else you may be using. And one thing is really, really important. Code reviews is not a place for coding style wars. If you want to argue about indentation and spaces and things like that, you can agree on a code style with your team, have coding style templates, the same one in IDE, and you can use some tool like checkstyle or something to make sure everybody uses the same code style and the code is formatted in the same way. Wasting your time on counting the number of spaces in a code review, it's a very sad way to spend your time. So do not do that. There's a number of things that you can do as a code author to make sure the reviewer spends their time efficiently. And these are the things actually that are generally best practices, and these are the things that you should be doing anyways, whether you do or do not do code reviews. Review your own code. And were studies that showed that reviewers who were looking at the code double-checked by their authors, they found 50% less issues. So just by simply spending a few more minutes looking at what you just did, you reduce the possible issues by half. That's impressive. Commit small changes. We do all know that it's generally good practice. It's good for continuous integration. There are less merge conflicts. It's easier to revert. And imagine if you have a commit where you have a feature, a bug fix, and a refactoring on top. It's going to be really, really hard for the person reviewing this code to make sense of it. What happens here? Why is to separate these things? It's really confusing, and it's better to try to avoid it as much as possible. Document your code to provide more context to the reviewer and provide meaningful commit message. That's also helpful to give the reviewer more context. As a reviewer, you should not postpone doing a review. Now, it doesn't mean that you have to drop everything you were doing as soon as you receive a notification and start doing code review. No, but it's possible to find time within 24 hours. You can do it after lunch. You can do it before you leave the office the same day or first thing in the morning. And it doesn't have to take too much time. Now, there are studies that say that 60-90 minutes is enough as the time that you need to spend on code review. But some people argue that it's actually 10 minutes. And then again, it depends how familiar you are with the code that you're reviewing, how big is it, the change. If the commits are small, they're generally going to take a lot less time to review them. So it may be 10 minutes, it may be half an hour or an hour, but it's still possible to find that time within 24 hours. It is important to understand your project needs. And what I mean by that is, if you don't know what to be looking for, you may want to consider, in every project there are complicated areas, there are hot spots, and you may want to pay special attention to those parts. For some projects, different aspects may be more important. For instance, if you have a performance-critical system, you may want to pay more attention to that aspect. Or if security is very important for your application, that's something you need to pay to consider and pay more attention to. So from understanding how the application you're developing is used and where are the problematic zones, already will help you to understand which exact things you may need to be looking into. But you may also want to apply your expertise. Like I said in the very beginning, that we come with different background, we have different experiences, and if you are particularly knowledgeable in certain areas, for instance, speaking of performance, that could be some practical tricks that you know of. And if that's applicable to the new change, then by all means, bring that to the table. It will make the code better and your team better. What is it do we want to look for in a code review? The topic is huge. There's so many things, and the problem is it largely depends on your project, on how it's used, in which language it's written, and what do you want to achieve with it. But I'm not going to give you a magic recipe. There is none. But I'm going to give you a few pointers of the things you may want to consider, or maybe that they will give you some sort of idea which you will develop and see what what is it that you can find useful in your particular project. So there is general and business logic. Things like correctness. Does the code do what it's supposed to do? If you have requirements, does it meet the requirements? Then we have coding errors. This may be accidentally using and instead of or, off by one errors, or accidentally pointing to a test database, stuff like that. Business rules and logic. If you send a notification twice instead of one time, that's annoying, but not as bad as if you accidentally give 55% discount instead of 5%. That can seriously damage your business. That's something that only you can spot, understanding the context. User-facing messages, are they clear? Are they correct? Then there's things like architecture and design. For instance, is the code in the right place? For instance, if it's related to orders, is it in the order service? Is it reusable? Or could it have reused something that you already have? Is there maybe a necessary duplication? Are there correct data structures used? It's surprisingly how it's simple to misuse data structures. If does it follow solid principles or domain-driven design or any other design paradigms that your team follows? Is it over-engineered for no particular reason? Sometimes the code may be too complicated because there's an intent of a future feature, but in some cases, it's just a person showing off. And that's not the best reason for overcomplicating the code, because normally when the code is too complicated for no reason, it brings more problems than a simpler solution. Then, of course, there is readability and how maintainable the code is. Everybody familiar with this quote, right? Right. So you may want to consider if the names reflect what they represent. Can you understand just by reading the code? Can you understand what it does? Because chances are, if you cannot understand it, the next person who ends up maintaining it will not either. Is it documented? Test coverage. The thing is, with test coverage, yes, you have tools that will check how well this code is covered by tests, but 100% test coverage is a real goal for any team. So it is important to understand which important cases have to be covered by the test. And you, as a developer, have the understanding of the context and which parts have to be covered by tests. So you may want to check if those are covered or not. Then a huge topic is performance. And the first thing you want to check is if you have requirements, if they're met. If you have performance tests, you may want to see if the new changes had a negative impact on those. And then there are common causes of performance problems. For instance, when remote services are overused when it could have been done with a single remote call, or you could have cached things or batched. And then the problem is also in, for instance, mobile and wearable devices. It's not only a performance problem, it can also cost you better life, better life, not better life, but then sometimes using locks can result in poor performance and deadlocks. You can check for potential memory leaks or if connections and streams are close, it's really easy to forget that. And then one of the offenders has too many calls to database. Like for instance, you should be able to see, right? Line 19, it seems innocent, but these are individual calls to database inside a for loop, and you have no idea how many of those you will have in the end. Then there's a huge topic of security. Again, the worst offender here is third-party libraries. So, of course, you can, there are tools that allow to check for vulnerabilities and dependencies, and you can run them on your continuous integration server. But as a reviewer, when you're looking at a new change, one thing that you can do is to check if it introduces new dependencies. Do the new paths have to be authenticated? Does this data need to be encrypted? Do you manage properly passwords, encryption keys, and other secrets? And there's also a gray area of potential problems. For instance, Java util random. It is not cryptographically secure. This may be perfectly fine if you're just generating a random number, but if you're using it for session IDs or password reset links, then you may want to consider using secure random. And there are many, many things like this that are hard to miss because they are may be a problem or may not be a problem. If you're interested in the topic of security, here are a couple of links I find useful. So the first one is a dictionary of software weaknesses, more like a small Wikipedia of software weaknesses. And then the second one is Open Web Application Security Project. They have a lot of interesting articles on the topic of security. And they have a code review guide which dedicated entirely to security issues. The first one they released in 2008, so it's pretty old. But they're working on the version 2 right now. It's in the alpha stage. And it's incomplete, but it already contains a lot of interesting and useful information on the topic of security. So if that's what's important for you, check it out. I said I will not talk too much about the code review tool, but I felt that there are a few things that I need to mention about Upsource. Code review can be sometimes a frustrating process because you're used to all the power of your IDE. You have static code analysis, navigation, you have many, many, many features and tools there. And most of code review tools give you syntax highlighting, and that's it. So you feel like you have no context, no understanding what's happening, and it's maybe really frustrating. That's why what we did, we got IntelliJ on the server side in our code review tool. So you get static code analysis like in IntelliJ, and code navigation, and find usages. And if that's still not enough, we have IDE plugins, so you can just do all the code review inside IntelliJ IDEA. And we thought This way it should be a lot more easier. And these are actually screenshots from Upsource, not from IntelliJ. So even if you know how to do code reviews, even if you know what is it you're looking for, even if you have your process working smoothly, there's still a way to mess it up. And there's that. There's us as humans who have to leave feedback, who have to deal with feedback. A funny thing is, we have to deal with a lot of feedback from QA, our users, from each other, and yet, when it comes to us, when we need to provide feedback, many times we're just terrible at it. And I'm sure some of you have seen this tweet. So there's a person, or several people, they're reviewing code. Probably happened to some of you that you saw something and you felt that way. And then they go ahead and they write comments, and they share the ways to improve it, and they write everything they think of it. And then the next morning, the person who wrote it, probably happened to this guy, comes to work and reads the comments and feels like this. Did it happen to you? How many of you felt that this way? At least once. Be honest. Right? Happened to everybody, at least in the junior years. So we have to learn how to give feedback. And there are many people who are saying that it's not personal, that you have to separate code from the author. And that is not true. The author of the code put some thought in it, some reasoning, his or her experience. So, well, hopefully not too many emotions, though. But it is personal. It is this person's thinking. And that is exactly why we need to think of how we provide feedback. There is no such thing as code that is no one's, and if we review it, we need to understand that there's a person behind it. So there are extreme cases, for sure. There are some people who feel that it's fine to review code like this. I'm sure you've seen this. It was everywhere. It may work probably for some unique teams, but in the majority of companies, in the majority of teams, being rude will not bring you much, or it will bring you nothing, except for people pissed at each other, and generally this will not go anywhere. You will just be fighting over calling each other names and things like that. So it is important to learn how to give feedback, and the first thing is normally not to be rude. It's as simple as that. Just don't be rude. We're all people, we're all teammates, we're colleagues, we're all professionals. There's no point in being rude. Do not dictate. If you see a problem and you say, well, this is wrong, fix it, without any reasoning, without anything, the person who receives this comment has a few options. The first one, just, well, shut up and do it. The second option is to start defending themselves, because they probably thought of the solution, why did they do it this way? And this third option is just to ignore it. If there are people dictating their opinion, you can just ignore it. And that's the worst thing that they can do, because if there was a problem, it doesn't go anywhere. It's not fixed. If the person dictating their opinion was wrong, there's no discussion. And the whole point is to have a discussion, technical discussion, engage in one, to find a solution to a problem together. So the best way to achieve that is to ask questions. Did you consider this? Did you think of that? What happens if? And so on and so forth. This way, first of all, you give the person credit for already considering this scenario. If they didn't, they will not be as offended as if by your question as if you were dictating it. But if they did consider it, in fact, you may learn something, because they will explain, well, I did it this way because in this case, this is the best solution, and you will learn something from them. And in the end, by asking questions, you engage in a technical discussion, and by dictating your opinion, sometimes you get things done faster, but not always it is the right way to do it. And yes, it is okay to argue. It is okay to defend your position. It is okay to disagree, because every problem has many solutions. And the question is, if the solution that you see is up to the quality standard that you have in mind. Because we all have some quality standards, and above it, it's all about trade-offs. You can't expect everybody to do things exactly as you would have done. So if it meets your quality standards, maybe there is no point in arguing about how you would have done it. But if it is below, then it makes sense to try to make the person see how it doesn't meet the standards. It is important to be sensitive to cultural differences. Some people are not, do not speak the language very well, and they may appear to be too direct or rude sometimes, and not necessarily meaning to be. But some people know the language too good, and it's hard to understand what they're saying, like in this famous example. Can you read from there? All right. It is equally important to know how to receive feedback. And the first thing here is to contain your immediate reaction. So if you see some comments on your perfectly written code, and some people are tempted to get very, very defensive and well, I'm not saying go to the desk of a colleague and punch in the face, but some people have temper, and they try to defend themselves without even giving it a thought. And the best thing to do is just to stop for a second, maybe for 5 minutes, give it a thought. If the person is not right, or you think is not right, then again, ask questions. Ask questions, engage in a discussion, and try to explain your reasoning behind your solution. The other person may learn something from it. And then the last thing is, it doesn't have to be all about problems. When you see somebody's code and you learn something, tell about it. If you see an interesting solution, say good job. Because we receive a lot of negative feedback. So this doesn't work, this doesn't work, and this doesn't work, and this looks ugly, and this is slow, and so on and so forth. We receive tons of that. And when you see particularly elegant solution to a problem, say it. Because we all sometimes need just a little bit of encouragement and to see that somebody appreciated what we just did. And that's it from me. Thank you.